We will do a quick recap. Last session was kind of going through the slides only. So, machine learning, it is the field of study that gives computer the ability to learn without explicitly programmed. So we don't have to. In the traditional programming method, we used to program the system. Here, the system will learn itself and give us the output. So, a better definition of machine learning is a computer program is said to learn from the experience E concerning some task T and some performance measure P. Three terms. One is experience, the other one is task, and third one is performance measure. If its performance on T as measured by P improves with the experience E. So we have a task and we are measuring its performance, and there is some experience it has. As the experience increase, the performance should improve. That is what is expected out of machine learning. And in the traditional programming, what we used to do is we have a problem statement and we have some input data. We will create the rule and we will get the output. If output is wrong, we will correct the program again and we will change the rules. Based on the rule, it will work. But in machine learning program, okay. So this is the example of traditional programming, how we used to do the spam versus ham. So spam is the spam mails and whichever is not spam, we are naming as ham. Here what we used to do is we have a from subject and based on the domain, we will put a rule telling check if maybe if that based on the email address, we will put a rule telling check whether that domain is from the spam.domain.com or whatever domain we feel it is. It is a spam. We will create a rule, and based on that rule, the algorithm will process, and we will get the output. And that output, if it is error, that is again a manual correction. When we see something else is coming as a spam, we will put add that again in the row. So that's how we used to do in the traditional programming. And now what the system in the machine learning part, what the system does is we have the same problem statement and same input. Using that input data, we will create a model or algorithm, and that algorithm will give the output, and that output itself will go back to the system and they will correct it. Means if there is a issue, if there is a error, that error will go to the algorithm and algorithm will learn from that experience and it will correct. So that's how we have that training data and test data concept. So when you get a business problem, for every problem we shouldn't go with the ML. Once we complete the ML, we will have a tendency to go with ML for all the problems. But we should check this, check with which one. And see if that problem can be solved by simple rules. We should adopt that traditional programming method. If that cannot be solved, then we should check. There are some solutions, automated ML solutions, which is provided by the providers like Azure, Microsoft, and all. They have provided some solution. If that works or not. If none of these work, then we need to create a model of our own. So, what is a training problem? For a training problem, we need to have three features. One is we already mentioned, right? E is experience, T is task, and P is performance. So task is the so for every problem we need to identify which is the class of task, what is the performance measure we are trying to add, and what is the source of experience. Now I need some help from you. I'm audible, right?
Yeah, yeah.
Okay. So you all know checkers, right? The game checkers. So in that game, we need to define these three metrics. One is the class of the task, performance measure, and what is the source of experience. So for the first one, I will try from means whatever is given. So for the checkers, playing checkers is the task, and the percentage, the performance measure, what we are doing is how many game we have won or against the opponent, and experience is the number of means each time the player plays with a opponent or the self playing self test whenever they do, each one is a experience for the system. They will store that information in the database. So we have T as task and P as performance and E as experience. Now for the handwriting recognition learning problem. Can you think what will be the task, performance measure and experience?
Task will be recognizing symbol,
Hmm.
and the measure of performance to be improved on is will be correctly identify the symbol.
Correct.
Yes, and the source of experience will be if uh, if he has similar kind of something.
Yeah,
If I'm,
if we provide the labeled data
uh-huh.
or by learning means each time it will learn, right? If it
Mm-hmm.
has correctly identified, that will go as the their
Okay.
experience.
Okay.
Next, a robot driving learning problem. So robot is driving a car, so it has to learn. So what is the task, performance measure, and experience here?
Driving a car safely is the task.
Yes,
Performance measure is uh, minimal accidents,
yes.
and experiences to uh, learn from your accidents.
Okay, that is one thing. The second, before yeah, getting into accident itself, it can learn. Means it has that image
Right.
into their system, right? So from the other drivers, it will learn how they are moving the steering and all from the recorded with the angle and all. It can learn.
Hmm. Okay.
So for these kind of questions, there is no correct answer. Whenever we write right, we should be able to justify it with proper. We should be able to give proper justification.
So, sorry.
Go ahead.
Uh, So we spoke about this Chinese checkers thing, right? So,
Hmm?
of course, if the system would learn, we said that system would learn, based on victories, right? So, if I am playing against the system, or and the system is learning from me, I may be making a mistake, and the system may be learning that mistake, right? How does the system know it's the right move?
Correct.
Does it have to wait till I win and then it understands the pattern?
Correct. Even if you lost, right, you might be moving. Means till the end of the game, you might be moving the correct strategy, and
Right.
maybe last two three steps you might be playing the means you might be making a mistake. That's where system needs some help in labeling. So in that case, the same problem they have explained it on the same checkers problem. So the first step is determine type of training experience. So training experience can come from this games, the either games against the expert or games against self. It can self play, right? Both players can be computer and then it can play. So some these two are just visualization, but they will have a table of correct moves. That's the input it is system is expecting from a expert gamer. One is game against expert. It will watch it and it will see who has win. So based on that, it will write the strategy. But there, the problem will arise if the opponent has played well till the end, and maybe last two three moves they have played, they have made some mistake, but system will not be able to identify it. That's where when it play against self, it will do all those analysis. It will put means all these strategies it will do against. It will make minor changes and it will try to analyze. So that is one way it can gain the experience. The second way is an expert can tell them, we can give an input like a label data we can give, and with that it can gain experience. So once it has that means with that experience, it will try to determine the function. So okay, before coming to target function, we need to learn couple of things, but I will just cover this and we can see it later. So target function is the what the result it is trying to achieve. That will be the target function. So it can be a board move or it can be the value we whatever that we the move then with number it will represent, right? So both can come as learning to the as the target function do means what is the next step, that will be the target function. And with this it can create multiple algorithms with whatever it has learned, that with that function, the function it can represent either as a polynomial linear function or artificial neural network. And with that function it can create a algorithm. For each one we need to decide what algorithm we should use, and based on that algorithm it will complete achieve that target. This is the general steps in any of the machine learning problem. First, we need to identify that, determine the type of training experience. We should have a target function, we should have a problem statement, and then determine how that function we should represent. And based on that function, we should decide which algorithm we should use. That will be the role of a machine learning engineer. Any questions till now?
So, could you please go back to the previous screen?
It's not allowing me to come back. Can anyone help me? The previous button is disabled here.
Oh, actually, so never mind. So the correct moves table was mentioned, right? So how the entry is made in that table, right? When is that entry made in that table? After every move.
We
Um,
should validate what is the system. Means system will be making entry in some table and based on their understanding, right? So someone should validate that and correct it.
okay. All right.
So there can be a situation. Okay. So suppose that there are 100 ways of doing something. Okay. But after some time, after learning that point, those things, after some time, okay, someone made very unconventional move. Okay, which also led to the winning.
Mm.
Okay. So here I don't see that through machine learning in the first attempt. Okay, the machine is able to identify that it is going to win the result.
Mm.
Is it so? Is it am I going in the right direction?
So, so it is like this. Whenever it learns something from the expert or by visualizing some event,
Mhm.
it will try by itself to see whether that works. That will be the game against self. It
Mhm.
it will do minor tweaking of each data set and it
Mhm.
will try to play the same game.
Mhm.
So if it is means the system is intelligent enough to identify
Mhm.
which whether it is a correct strategy or not. But there are cases it fails. That's where some cases we are able to defeat it also.
Okay, so it includes these situations where there can be some unconventional way. So out of 100, you can say that 0.01% can be unconventional. People can play that move, isn't it? Which is not been very much famous or not been recorded somewhere. Okay, so it can be included by self learning.
That's correct.
Okay, okay, fine.
Okay. So I will just go through this. Uh, any four types of problem where machine learning shines. So, any it means for there is no right answer to it, but any problems which you think where machine learning can be used.
Image recognition,
Hmm?
um, um,
Classification type of problems in which we need to classify things. Suppose that we are taking images from the camera, okay, and there are some for some images the user has opted it as a harmful, or and for some images it is like that are usual or known. For so machine can identify those objects in the image and categorize that or classify that.
The, classification is the step which we are doing, and image recognition or image categorization is the task which is there.
Hmm,
So
hmm,
one is image recognition.
hmm.
Other than that,
It can be in a medical field, learning the type of disease based on
correct,
the images and
correct. Okay, let's see the solution.
We have one question. This I am little bit confused about AC. I mean AI and ML and DL. So because chess and all we are using AI also. No? Chess and image recognition. AI and ML both are interchangeably usable or what?
Correct. Everything is under the same umbrella. EAA is a bigger one, and ML is a subset of it.
Okay. So in the chess and all, is it AI or how we can say that AI or ML? How we like in the driverless cars and all.
For the algorithm which we are doing, it will have both.
no, you can tell that you are. Sorry.
To my understanding, if system can understand and do the things right, then that all those things will be categorized under the machine learning based on the experience. Based on a experience, if system can learn and do, it will be machine learning. And machine learning is a categorization of AI. But AI has something else also where the system itself has the intelligence to do something. System will generate the intelligence to do the activities. It can make the decision. It's not based on the past experience. The system has will develop that intelligence to do something. Then that will also be under the artificial intelligence umbrella.
Okay, so that AI means system can decide something which it doesn't have an experience previously, and
AI
ML.
is a bigger umbrella. You can consider it's a bigger circle, and ML is just a subset of it, one attribute. So the rest of it, right? Anyone can correct me. I think this artificial neural network, deep learning, everything will come under the AI umbrella.
So, what I have read about it, that the AI is a superset, and then comes the ML as a subset, and then comes the deep learning. So, AI is, as Veena said, that it can learn from environment. Okay, so you don't have to give the problem that this type of experience you need. Okay, or you have to train something. As human, that if I go to environment and I haven't seen the swimming before, but I have see that some people are swimming, then I can learn by myself if I'm willing to. Okay, this is what the AI is. Okay, then comes to the ML. you need to give some data set, or you need to classify them some problem about it, that yeah, this is the problem that you have to learn, whether in a supervised way or in supervised way. That is called the, that comes under the ML. And then comes the deep learning, that is very specific, that you have data set and everything, that are very narrowed part. And this is what I have learned somewhere.
So DL means that I didn't get. Okay.
Deep learning, deep learning.
Yeah, yeah. So what's the difference between DL and ML? In case you can.
Um, so you can say that modes a subset of ML. If you consider a subset of ML, then that is DL. It means that more more steps has been defined for that machine. Okay, that then it comes under the DL, like that.
Okay,
So
okay.
AI, it means that no experience, neither it has been told that what type of experience you are going to gain. That is the AI. ML, that problem has been defined to you. Maybe some data is present there. It means that it can be supervised or unsupervised. In that is ML. But if everything is provided to you and every problem is clear to you, then it comes under the DL.
Okay, great.
Yeah.
We have DL in Excel.
So, you can correct this, but I recollect the first class of Prachi for data mining, Prachi madam's class, right? In that, she was kind of for deep learning, she was kind of giving an example. I mean, just, I kind of relate to that. What she was mentioning is that, we do our education from, LKG, UKG till, 12th grade, right? So, we learn first, we learn alphabets, and then from then on we try, we learn words, and then from that we learn sentences, and that's how, over a period of time we kind of learn, poems and other things, right? Interpretation of that. So it is, the learning is in terms of layers, right? So layer one is first grade, layer two is second grade, like that. In a similar way, deep learning is also a subset of machine learning where it requires one type of learning first before it can get into another type of learning. Um, so as a practical example, when I had read somewhere about machine learning, about deep learning. So a form of deep learning is convolutional neural network is what I learned, right? So I'll give you an example. X-rays, right? There are let's say there is a TB is a disease, and also sarcoidosis is a disease, right? Both of these they look the same to the naked eye, but there are very very minor differences which human eye can't detect, right? TB, there are certain kind of formations where you can detect sarcoidosis is an autoimmune condition, and TB, we know that it's a standard lung infection, right? It's only using this convolutional neural networks is where this university, they were able to, there is some research going on in some university in US where they are able to detect sarcoidosis is, as a disease which is different from TB. So they were able to differentiate, and they used deep learning only to do this, right? So how exactly they did, I have no idea. I just wanted to, share what I read, right? So
Okay. So, yeah, kind of. I was just referring to the books also. So, if we can just, based on the knowledge base which we have, right, or the Google search which we are doing, all those will come under the AI. But if we are using any algorithms like logistic regression and all, then it will come under the machine learning. And as the gra- uh, graph goes down, means we are doing more and more analysis to get the information, like you said, then we are doing some more learning, we are using some more algorithms. That's where means to if the graph is huge, then it is a deep learning which we are doing to understand something, if we are doing using more and more algorithms, then that means with some one or two algorithm we are not able to, or there will be some hidden layers and visible layers. So based on that, we are getting the data. So that then we will say it is a deep learning. So we need to see learn some of these algorithms. Even I'm not clear. One such example of deep learning is multi-layer perceptron. So based on those, which algorithm we use means, or it is classified that way. Based on the algorithm which we used, it will classify it as ML or whether it is a deep learning and all. So more complexity adds, then it will become deep learning. That's what I'm thinking. But let's see. Okay.
Okay, okay. Let's see how it goes.
Yeah. So we have seen some examples of machine learning, right? So whenever we choose the machine learning, we are looking if there is no other solution for it, or we have to do lot of manual calculations for it. One such example is the genetic composition which we are doing. So before, whenever the team used to do, they used to select some of the genes and study it. But once ML came in, they have more option to learn about all the other gene characteristics, to build systems that adapt to fluctuating environments. So, like the systems which detect earthquake or those things, we can know. Means the minor changes in those environments, we will be able to know with ML. The system will capture the data, and based on that data variation, there are prediction systems which will predict the weathers or the earthquakes, all those things. The system can predict it. And wherever there is a huge data, where we can, it help means where we need to do the data mining, there also we can use the ML. Okay. What type of machine learning algorithm would you use to allow a robot to walk in various unknown terrain?
So unknown terrain means it doesn't have an experience, right?
That's correct. When it goes to Mars, an example. So in that case, there is no option for us to train it, right? So it has to develop some learning of its own. Reinforcement learning is the one which they are using, but we can use in any of these algorithms if we have connection to those systems. Like for the mining environment and all, they will employ robot. So that area, maybe there it can be supervised. Similarly, in rigs, or one is rigs, second is any oceanography works whenever it happens, right? Those areas they can send, and there are experienced people who can provide the input. So we can use supervised, semi-supervised learning also here. But when it is sent to a totally unknown area where we cannot reach, then we will be using the reinforcement learning.
Now this reinforcement learning is a part of ML or is DL or
It's a part of ML. There are four types of ML: supervised, unsupervised, semi supervised, and reinforcement. Reinforcement is used for the self driving cars and all, but we don't have it in the scope of our syllabus, I think.
oh, okay, okay.
What type of algorithm would you use to segment your customers into multiple groups?
Classification, right?
Unsupervised.
We can use classification algorithms or clustering algorithms. Both we can use. So if we know how to define a group, the classification will work. Like gender classification, we can do male and female. But if we don't know how the customer behaves, then we need to use the clustering algorithm based on what they purchase or the age. If we know the age category and all, age category, gender category, we can classify based on classification algorithm. But if we don't know anything about the set of customers, then we have only option to, based on their purchase behavior, we can classify, we can cluster it. Those will become the clustering algorithm, unsupervised algorithm. Okay. So when we learned the spam ham detection, right? So when you do that, will you take the supervised learning problem or unsupervised learning problem?
Semi-supervised.
Okay, that's a safe answer. So kind of, I will ask the question in a different way. When you get a mail and that is a very important mail, will you expect it in the spam folder?
Mm,
No.
no.
So in that case, we will be using the supervised learning problem. When the system starts detecting it, right? Sometimes these mails will go to spam, but there are algorithms using unsupervised also. There are system using unsupervised uh, also. Based on the user behavior, it will send it to spam. So that's where whenever we get some important mail or whenever some customer sends it, they will ask us to check in the clutter or spam folder so that we will receive that mail. So there are some systems employing unsupervised learning also, but ideally it should be a supervised. Means on the ideal scenario, if it is a critical mail, then supervised learning algorithm will help.
So if there is a case where we can apply on the basis of the situation, whether it can be supervised or unsupervised, we can't say it as a semi-supervised like that. Okay.
We can. But whenever we are writing any answers, right,
Hmm.
they will expect us to put the justification also.
Makes sense.
So these are some of the applications of machine learning. All of it or most of it we know. In web search, we will be using machine learning. We can know the number of clicks of users or the pattern of the users coming in and going on. So coming into the system. In computational biology, the drug testing and all, based on the past experiments, they are to changing the drug composition and all, right? So there they are using. In finance, the credit frauds and all is detected by the ML. In e-commerce, customer churn is one of the important or most used ML algorithm, ML use case. And space exploration, whenever we are sending the robots to space or all those things, we are using algorithm. Robotics, information extraction, social networks, debugging. So any of these need further elaboration, just let me know. These are the common use cases which we are seeing. Similarly, other use cases where it is being used is in the data mining. So when you have a huge set of data, or when based on that data, we are trying to understand. So this is one use case. I think it was done by Tom Mitchell only. So in one of his recording, it has come. So what they are doing is they are taking the statistics of the uh, pregnant ladies, and based on that they are telling the delivery will be c-section or normal. Based on the previous statistics, they are telling based on the statistics of the patient. Similarly, GE is employing ML in their studies. So based on the data which they are getting from the GE instruments, right, in the healthcare area, they will predict the criticality of the patient. Other area where machine learning is employed is one is speech recognition. the flight movement, the flight path control, the text analysis is one of the common one, and object recognition. This we are seeing every day in the Google, right? We will get some of the images. When if it is one or two image, we can do, but when it has lot of images, right? Then we need some object recognition software for that. So first time we will be naming the label we will be providing. This particular person is myself, my husband, my kids, all those. If we name, they will select that and give us a that videos. It will in Google Photos. It will create some videos or some slides. It will create and send us, right. Similar way, it can be used. The other area where the image recognition is being used is to identify wanted criminals. So they will have some images into the system, and it will take the pictures from the CCTVs and all, and it will try to identify that person. Okay, these are the different types of machine learning which we have discussed already: supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning. The difference between these is supervised learning. We are giving the labels. We are giving some input data. Based on that data, system is studying, and for that we are using the algorithms like decision tree, support vector machine, linear regression, all those things. In decision tree, we have learned in data mining, we have learned a algorithm for the to identify whether we can go out for play based on the weather condition. If it is sunny, rain, humid, all those things we have learned, right? That comes as a decision tree. Like that, most of these algorithms we have learned in the data mining. So we might need to go back and refresh a little. So those algorithms will be needed in future also. In this course also, we might need to use it. And when it comes to unsupervised learning, we are not giving any labeled data. Based on the data, here we are using the clustering algorithm. Based on the features, it will extract the features, and based on the data, it will identify. The last class we have seen, right, whether it is a cat or dog. Based on the features, it will identify the image and classify it as two different animals. So there we are not giving the label data. So some of the algorithm which we are using is a priori, k-mean, clustering and all. So one of the common example which we have seen is in k-mean, we can tell the next. If we want to classify one cluster, one of the item, we will search the nearest neighbors, and based on that nearest neighbor, we will identify whether it is a triangle or square or circle. That identification it will do. That's one of the common example which is given for the unsupervised learning. And semi-supervised learning is, it has some labeled data, but it may not be having the complete information. So for some of the for this animal categorization itself, it will have some animals classified and some are not classified. So whichever is not classified, it will try to identify based on the features which class it should go. And last one is reinforcement learning. For that also, these algorithms we might not be learning as part of the current curriculum, but this is also part of the machine learning model.
So, quick question. Sorry, I mean, there's no provision for previously, right? So, this semi-supervised learning and versus supervised learning, we are using a combination basically, right? So, we are saying that so to identify a cat, some of the images maybe we will say yes, this is a cat, and no, this is not a cat, so that the system will know, and by itself also with a lot of images, system will understand itself. So we use this kind of algorithm for this, right? So, but in machine learning, we are expected to choose one of these four, right?
That's correct. Either supervised, unsupervised, semi-supervised. That's correct.
Right. So, my point is in terms of the complexity and arriving at a solution faster, a combination of both is always good, right? So, why would we? So, only in the cases where we cannot do a supervised is when we, like the example that you gave about Mars, is when we get into reinforced learning where the learning may take a lot of time
Correct.
versus supervised learning where we can arrive at it faster or we,
Correct.
we can get accuracy faster, correct?
Correct. That's fair. Means always our projects will be on critical timelines, right? So if faster way is supervised learning, we should go for that. But in some cases, when we go for supervised learning and we will fail, that's the time we will think of semi-supervised or unsupervised.
Okay. Okay.
So this is one example of supervised learning where we have given the label of cat and we have tuned the machine. And now when we give the input of the test data, then in that there is an image of dog. So based on what it has learned, it will just classify whichever is cat as cat and whichever is dog, it will put as not cats because that's the learning which we have given to the system. So the types of algorithm which we are using is classification or regression. Classification, if it is categorical variable, where we can classify it, then we will use the classification algorithm. Where we have the proportion or percentage, all those things, we will use the regression algorithm. So in this case, we are checking whether the student is pass or fail. So we can check two ways. If there is already a marking based on mark, if we can do, we will classify it as pass or fail. But based on percentage, if we are taking, we create a graph based on percentage. The current model which we are working, the CGPA, not CGPA, right? The normalization one. So that is a kind of a regression one. So we are checking the highest value of highest mark which is obtained by the student. Then based on that, we are calculating the percentile, right? So that way we will not be able to classify it. We need to use regression algorithm. And I'm not telling that case we need to do, but in general. So where we are not able to classify it, we don't have a distinct category, then we need to go for the regression algorithm. For example, if it is male or female, true or false, spam or not spam, we have the correct classification. Whereas to predict a continuous value like price, salary, age, and all, we will use regression algorithm.
So this regression is for continuous and classification is for that what is the categorical.
Categorize.
Okay.
Yes. And in case of unsupervised machine learning, we are not giving any labeled data here. We are just giving this data. So based on the data, it will extract the features and it will classify as similar groups. So it will cluster the data. All the cats, it will cluster one as one group, and all the dog, it will cluster as another group. So based on that, means it is basically categorizing the data. Sorry, clustering the data. So in such cases, we can use unsupervised learning where we don't have any information of the data. It will just validate the features, and based on that features, it will arrive at a conclusion. clustering, anomaly detection, association, and algorithms all are used for the unsupervised learning. In clustering, we will just group based on their purchasing behavior or some grouping we will do and identify the customer categories. And in association, we will be checking when they purchase milk, are they purchasing bread, are they purchasing cheese based on their previous data. We are trying to arrive at some association between these customers. These two we have learned in data mining. And when it comes to semi supervised learning, this is the place where we will be using the semi supervised learning. The input data has orange, banana, and apple, but we have only partially labeled it. We have labeled orange and banana. We don't have any label for apple. In that case, the system will be able to predict it as a apple. So it will validate it's a different. It may not be categorizing it as apple, but it will just validate the feature, and for that feature, if there is any definition provided, it will correctly identify. Otherwise, it will identify as a different cluster. And this is the reinforcement learning. Yesterday we have seen the rewards and all, right? That is the one where we will get the input data. We will do we will process it through the algorithm. We will make one action. If action is correct, it will reward it and make sure that action is captured. That will be set as, that means that percentage will increase for that particular, means whether it is correct or not, it will have more point to that. If it fails, then there will be a penalty, and for that particular action, they will reduce some mark. Means the prioritization will be reduced. So that's how the reinforcement learning works. Any questions till now? Okay. So we can, when we get the data, right, we can process it in multiple ways. So that's where we have this batch, mini batch, and online learning concept. Batch is the full data, whatever full data we have for the training, we are sending all the data to system and getting the input out and adding it for the processing. Whereas mini batch is, we are splitting the data into different levels, and each small set of data we will send and try to identify the result. And online learning is continuous processing of the data. In addition to that, we are using either an instance based learning. So based on an instance, one particular instance, it will check the similarity. The KNN algorithm is a example of instance based learning, where it will check for the similarity around it. In, in a subset of data, if the similar use case is there, it will classify. Otherwise, it will expand that search. Whereas in a model based learning, it will classify that data completely. So the entire data will be used to create that model. So these are some differentiation of these two models, instance based and model based. So in both cases, we will be preparing the data to train the model. These are for the supervised learning. So we will be preparing the data for model training, train the model from that means to get the parameters. So in the model training, we will have model based training. We will train based on the training data, we will train the system. Whereas based on the instance based learning, at that point of time, it will not tune the system. It will wait for the system to tune at a later stage. That's how unsupervised learning also works. And once the in the model based, it will, I will cover the model based first. So we will get the data, we will train the model, and the model, the model output will be that model will be stored for the next set of data. So the whatever rules we are giving based on the model, right, based on that only it will get the new data and produce the result. Whereas in instance based, that rule will not, there will not be any rule generalization before scoring. First we will see the data, and based on the nearest neighbor it will try to, or based on the small subset of data it will try to arrive at a conclusion. Sorry, the answer came. So, what type of learning algorithm relies on similarity measure? We already mentioned this. Where the instance-based learning is used, it will try to see the similarity around the different similar instances around it, and it will try to make a prediction by using them. So these we will learn a little later on the model parameter and the hyperparameter concept. I will just skip this one. So how this is how the model based algorithm works. The whichever we have seen before, the model based learning algorithm search for an optimal value of model parameters. It will first find the parameters such that model will generalize well to new instance. Whenever we get the new data, it will do based on whatever parameters it has taken from the first set of instance. We usually train such systems by minimizing a cost function that measures how bad the system is at making prediction on training data, plus a penalty for complex model complexity if the model is regularized. To make predictions, we feed the new instance features into model prediction function using the parameter value found by the learning algorithm. So the normal supervised learning where we will input the data, it will generate some rule, and based on the rule it will produce some output. Then we will provide the test data. If the same output is not there, then there is a issue, we need to retrain the model with the next set, the new set of data. So that process will continue till the system can produce the generalized regularized output. If your model performs great on the training data but generalizes poorly on the new instance, what is happening? Can you name three possible solutions?
The training set was not enough, maybe.
That is one reason. If a model performs great on the training data but generalizes poor to new instance, model is likely overfitting the training data. Possible solution?
And sometimes data will not be sufficient, right?
Correct. We have very less data. Based on that, we are arriving at a conclusion.
Yeah,
Then,
and we may take two, three samples instead of one sample.
correct, for regularizing the model. Yes,
Yeah.
that can be done.
Oh, Nagesh, good evening. Long time.
Yeah, yeah. Sorry, Manoj. I was little bit, some reasons, right? I'll explain. I'll
Okay.
catch you tomorrow.
No problem. Anyway, you came. It's good. Great. Yeah. Okay.
Thank you. Yeah.
And the other reason is the outliers in the data. The training data might be good quality, but there might be some outliers which might have given a wrong result. So these things we need to see. There are other challenges as well with the data. We will see in the coming sessions. Manoj, do we have stat or should I continue?
If you can continue, it's fine. Otherwise, we will. If it's okay for you, you can continue.
I will take 10 more minutes and then close.
Fine.
Anyone want to attempt? Pick the supervised machine learning problem from the given set.
Uh, Actually, it's a little Actually, can you maximize it little? I'll
I might be.
the supervised machine learning. Actually, my screen is also full. Clustering is supervised. The sentiment analysis is supervised.
Sentiment also is supervised, right?
Yeah, yeah. And alpha, I don't know. AlphaGo, pathfinding, I don't know.
Clustering is unsupervised. Uh, class
Segmentation is supervised. Sorry, clustering is unsupervised. Yes, segmentation is supervised. Last,
sentiment analysis supervised.
yeah.
Clustering is unsupervised. AlphaGo and pathfinding is reinforcement learning.
What category it comes under? Reinforced means it's
Reinforcement. So AlphaGo is a gaming, right? Based on the yesterday we have seen the same scenario where based on the player, it will detect or give detect the penalty or give some reward, and then it will proceed to next step. That's how AlphaGo works. Pathfinding also is the same. To find the shortest route and all, it will use the reinforcement learning.
uh,
It,
Veena, can we take them as actually they will come under this with supervised or unsupervised? Actually, it's okay reinforced, but reinforced again it will come under these
no,
any of these or
it
what?
is a separate classification.
Separate, entirely separate.
Entirely separate, but we don't have it in scope now. But just we might get this as examples. Means like when we do the MCQ and all, we might get this, but this is not in our scope at this point of time.
Okay.
Veena, could you actually, Nagesh says that's the question I wanted to ask also. Could you differentiate use case of reinforced versus unsupervised?
Reinforced learning we will use when we don't have means if wherever the system has to learn. Okay, wherever the in the unsupervised one, we will not be training the system, but still we will be validating it. But in the reinforcement, the system has to learn itself from its mistake.
So even validations it has to do.
There is no option, right? Once the system, like the example which we told, the robot going to Mars, there is no option for the engineer to change it or correct its path. So such cases, it will fail once. Then based on that learning, it will try to change the path. It will go that way. It will learn.
Hmm. Correct.
Okay. So coming to the next one, which one is a metric in classification? This we have learned in the last in data mining. We have learned all these mean, p value, root mean square, and F1 score. So in these all these, which one is used in the classification?
I think F1 score. Everything comes under regression, definitely. Mean will not come, but RMSE will come, p
Yeah.
value will come, F1 score also will come for regression. But classification, I think
F1 F1 score will be in the classification where we will be classifying as true
yeah,
positive,
yeah, correct.
true negative, and all right.
Yeah,
So
yeah,
in that we will be using the F1 score.
F1 score. The rest everything will come under, even all will come under regression, right?
That's correct.
Yeah.
What is correlation?
Correlation, how do we different feature? Okay, how
How
they
different two features are, mean difference between two features, a measure of dependency between two features, metric.
yeah, a measure of dependency between two features,
Okay.
uh, and how different two features are also correct. And metric correlation is a metric. Yeah, somehow it is a metric also.
Most so kind of difference is similarity and dissimilarity we are working, right? But
Yeah,
correlation is mostly the dependency. If
yeah,
one goes up, the other should also go up or go down.
correct.
So
But actually, dependency. Yeah, one is influencing the other one, and one is based on the other one.
huh. In that case, we will be using the correlation. We have learned what I forgot actually. We have learned some terminology, some Pearson coefficient and all.
Yeah,
So
yeah,
that is in the correlation.
yeah.
Mention the non-parametric model. I think non-parametric model we will learn later, but by seeing the name, any of these coming as a non-parametric,
It's KNN.
correct. So we are not defining, giving any parameters. It will be looking into the nearest neighbor and getting the data, and classifying, clustering the data.
Yeah, it's unsupervised. Yes.
This is the pathfinding example in reinforcement learning. And this was the classification, accuracy and prediction, which we have learned, right? The F1 score is used in this. Some sample data, and I have put some reference which you can go through.
So Vivek and Sibasis and others, if you are interested, we can do the statistics after this one. That grade 12 questions, right?
Yeah, yeah, sure.
Yes, yes, yes.
So, Veena, Manoj, and all, I just want to share my experience for 2 minutes, okay, about that the gender classification program that we were discussed in the last discussion, isn't it?
Okay.
Yeah. So actually, it is based on the last letter of the word. Okay. On the
Hmm.
basis of that, they classify the gender as male or female. Okay. And
Okay.
then when I wrote the program now, so mostly I worked on the Android and Kotlin. It means Java and Kotlin. Okay. So I'm
Hmm.
not that much familiar with Python. So that is also one thing that was something that I feel like that one should be enough proficient in Python. I was able to understand the code. That is altogether different thing. But still, to write code by your own, you should be enough proficient. Okay, and there are libraries that do things for you. It means that you don't have to write algorithms, but you know how to implement those things. Okay, so it takes data, it classify whole the data, divide the data, okay, in training data and the test data, and then use that training set for the test set. Okay, but here there is also what is that you can say that we have to tweak a little bit. That name can be mostly be in the basis of the country or the region, isn't it? It cannot be like that for the whole world is the similar thing. So I think that where our role comes into play, that when we get the data, how we do the feature engineering and all. So I think so.
Okay.
It was
Okay.
a simple problem. It was a very simple problem, but still there are two challenges that I have seen. That one should be proficient in Python, and other thing is that that library do everything. Mostly library do everything. You don't have to do anything, but still you should be enough with the concept, enough strong with the concept, and able to do feature engineering in that.
Okay.
So yeah, I have seen that some GitHub examples where the some that Korean students have done this problem with on the basis of the region and the country.
Okay. Okay. Got you. I'm sharing back for a minute.
Hmm.
Just wanted to show you what we have covered till now. Uh, so this particular chapter, right? We were going through this one, machine learning by Tom Mitchell. This textbook we are referring to, and the first chapter I just covered, not come fully, but almost all the basic concepts I have covered here, and all the problems also I have taken from this only. And I have these things we have covered already. And there are five exercises in that first chapter. So if time permits, just go through this. You can ignore third because it's a gradient descent method, which third and fourth you can ignore. For first, second, and fifth, you can just go through. For fifth, right, like you mentioned, when you mentioned the Python programming only, I just go through this. This has the already Python program implemented for the same problem. So if time permits, just try to see what is being implemented. They have used only the no, common functions only. Oh, this didn't come as. I will put it in the our chat, WhatsApp chat. So just try to go through this. That will help.
Mhm.
And also share the PPT also so that we can go through the once again.
Yeah, yeah, sure. We'll do that.
Veena, this is bits PPT, क्या?
No, but most of the
No, no,
links
it
I
is.
have taken from that only. Means from our PPT only. I have taken the topics.
It's Veena's
Okay, okay.
PPT for PF session.
Kind of it is from that textbook only. I was referring to that text for most of it. But this is the concept, whatever we have covered till now, right? That is from this only. I haven't deviated from that, but basically based on that textbook problem. So I think the teachers has some. They will have the common template, and each teacher has taken in different way. So they are taking their own example and sharing the details. So this one, I think I have added that also. Most of this is from either Medium or I don't remember, but I think I have added that link also here. Hmm, let me search it. I have seen that from one of the session document this website only what our teacher is covering, man is covering. So I will share that link as well. Anything else?
So maybe tomorrow we can go through that exercise, right? Chapter one, textbook.
Yes, we can go through it. The Python program and all right. We can go through once. My score is whoever can go through, right? If they once they go through and come, it will be easy. Otherwise, we will spend more time in the class.
Oh, okay, okay. And this labs also are, they have, I think, scheduled the labs and provided the lab questions and all, right? Maybe it's
Okay.
related to this.
Mm, For Python, right, we can use the Anaconda.
The lab questions or lab modules they have mentioned in the bits have provided, right? Some materials on that. Okay, I will check it.
I need to check. I haven't gone through.
Yeah, because I heard the instructor saying that everything is uploaded, the lab modules and all.
Okay.
So if you check
Yeah, so
with
it
them.
is actually it is at the end of this handout now. So they have mentioned that what are the lab problems. So it must be in this where we did that this computer network problem in assignments.
Okay.
Yeah.
Yeah. Thanks a lot, Veena. Thank you so much. See you tomorrow,
Thank
right?
you all.
Yeah, thank you, Veena. Thank you so much.
Thank
Yeah,
you. Thank you,
thank you,
Veena.
Veena. Thanks a lot.
And Veena, if you can just stand by in case.
I think she left the call, Manoj.
Oh, yeah, yeah, yeah. Okay, I should have told earlier. Okay, anyway, let's start. Let me share screen. You're able to see, right?
Yes, yes, yes.